Welcome back to another episode of Second Career Pilot.
Great to be here.
Today we're hitting on a really crucial area as you transition into the cockpit, especially thinking about flying in potentially more instrument conditions. We're talking about human factors.
Exactly. Yeah, we've gathered quite a bit of information looking at how our bodies, our minds, how they interact with the aircraft, the whole flight environment, really.
So the mission today is to kind of unpack those key human factors that can really impact your safety, your decision-making up there, especially when, visual references aren't as clear.
Right, and it's fascinating and maybe a bit unnerving how our senses, the things we rely on every single second on the ground, can sometimes just completely mislead us when we're flying.
Yeah, exactly. So we want to explore these sensory illusions and maybe more importantly, figure out how we can actively counteract them to stay safe.
We'll be touching on vision, obviously, but also the inner ear, that's the vestibular system, and even our sense of touch and position, the postural system. They can all feed us some pretty wrong information sometimes.
Okay, so where should we start? Vision seems like the obvious place.
Definitely. As pretty much every pilot knows, vision is our primary sense for flying safely. It's quite amazing how our eyes adapt, from bright daylight to very low light conditions.
Yeah, the cones for day, giving us all that sharp detail and color, and then the rods take over at night. They're incredibly sensitive to light, aren't they?
They are, and that difference in sensitivity, well, that's where some challenges can creep in.
How do you mean?
Because the rods contain rhodopsin, that's the visual purple, they're extremely sensitive. So a sudden bright light at night, bang, it just bleaches it out.
Ah, okay, so it takes time for them to become effective again.
Exactly. Valuable time. Even a quick flash can leave you sort of temporarily night blind. So the big insight here is you've got to protect your night vision.
Makes total sense. And it's not just sudden lights, is it? I read that things like smoking, alcohol, even just lower oxygen at higher altitudes can impact night vision.
That's absolutely right. Those are really important points for pilots. And it's also worth remembering your vision doesn't just snap back instantly when you descend either. It takes time to recover.
Okay. And what about blind spots? We have them on the ground, but are they different in flight?
Well, we have the physiological blind spot where the optic nerve connects. That's always there. But at night, there's also a night blind spot right in the center of your vision because there aren't many rods there.
So looking directly at something faint at night might make it disappear?
Precisely. So the practical takeaway is using off-center viewing. Don't stare directly at faint lights. And using a deliberate scanning pattern is crucial at night to pick things up.
Okay, understanding the limitations. And it's not just the eye itself, but how the brain interprets it, right? Like that Rubik's Cube example where the same color looks different depending on what's around it.
Exactly. Our brain is constantly using context, and that applies to size and distance perception too. Those shepherd's tables illusions. Identical shapes look different sizes.
Yeah, those are weird. How does that relate to flying?
Think about landing. If you're used to a standard runway width, approaching a narrower one can trick you into thinking you're higher than you are.
Ah, leading to a potentially low approach.
That's the core deception. And the opposite happens with a wider runway. You feel lower, so you might fly a higher approach. The counteraction is always trust your altimeter and any approach aids you have.
Got it. Now, about adapting to the dark adaptation. That takes a while, doesn't it?
It does. Full adaptation can take up to 30 minutes. You get a good amount of it may be moderately adapted within about 20 minutes, especially if you're using dim red light.
Red light used to be the standard, right? But I hear it has drawbacks.
It does. While it preserves the rods, it can really distort colors on charts, which isn't great, and it can make focusing on the instruments a bit harder. The recommendation now tends towards dim white lighting if you need to read things, especially in IMC.
And you lose that adaptation really fast with bright light.
Oh, instantly. A few seconds is all it takes. That's why the old trick of closing one eye if you need a bright light for a moment is actually pretty smart. Keeps one eye adapted.
Good tip. And increasing cockpit lights during lightning at night.
Yeah, that helps maintain some sort of visual reference and stops you from being completely blinded by each flash. It's also worth knowing that things like pressure altitudes above 5,000 feet, carbon monoxide exposure, even a vitamin A deficiency, or just being out in bright sun all day can hinder your dark adaptation.
Okay, so vision is king in VMC, but when those visual cues disappear, like going into cloud, That's when the other senses can start causing trouble.
That's the critical transition. In IMC, without reliable visual input, your brain starts paying more attention to your inner ear, your body's sense of position. And these systems can be easily fooled by flight dynamics.
So the key is recognizing these false sensations.
Recognizing them, yes. And then this is crucial, actively disregarding them. You absolutely have to rely on your flight instruments. This is where strong instrument flying skills become non-negotiable.
Right. So let's dig into the ears, the vestibular system.
Yeah.
You mentioned semicircular canals and otolith organs.
Yeah. The semicircular canals, think of them detecting rotation, pitch, roll, yaw, angular acceleration. The otolith organs detect linear accelerations, speeding up, slowing down, and also gravity.
How do the canals work? Something about fluid.
Exactly. They're filled with a fluid called endolymph. Inside, there's a structure called the cupula with tiny hair cells. When you start turning, the canal moves, but the fluid lags behind due to inertia. This bends the hairs, sending a turning signal to your brain.
But the fluid catches up eventually.
It does. Takes about 15 to 20 seconds in a constant rate turn. Once the fluid is moving at the same speed as the canal, the hairs straighten up and the sensation of turning stops, even if you're still turning.
Okay. Can see where this is going, the graveyard spiral.
Precisely. That's often how it starts. You're in a prolonged, coordinated turn, maybe losing a bit of altitude without noticing because the turn sensation has faded. You feel level or maybe in a slight descent.
But you're still banked and turning.
Right. Then, if you try to correct that perceived descent by pulling back on the yoke.
You just tighten the turn and lose altitude faster.
Exactly. All while potentially still not feeling the turn. It's incredibly dangerous. The lesson is clear. In prolonged turns, without visual references, trust that attitude indicator.
That's a chillingly clear explanation. Okay, what about the otolith organs? Linear acceleration illusions.
So these have tiny crystals, otoliths, in a sort of gelatinous membrane. When you accelerate forward, like on takeoff, these shift bending hair cells. This can create the somatogravic illusion. It feels like you're tilting back, like the nose is pitching up excessively.
So the dangerous reaction is pushing the nose down.
Right. Especially dangerous close to the ground. Conversely, rapid deceleration, like pulling the power back quickly, can make you feel like you're pitching up, potentially leading you to lower the nose and risk a stall. Acceleration feels like pitch up. Deceleration feels like pitch down. Ignore the feeling. Check the instruments.
Okay. And there are other specific vestibular illusions too, right? Like the leans.
Yes. The leans often happen if you enter a bank very slowly, so the fluid doesn't really register it much. Then, if you suddenly correct back to level, the fluid does move, creating a false sensation. You're now banking in the opposite direction. The instinct is to lean or even roll back into the original bank.
And the Coriolis illusion.
Yeah.
That sounds complex.
It's a nasty one. If you're in a steady turn long enough for the inner ear fluid to stabilize, and then you make an abrupt head movement, like looking down to grab a chart, it can set the fluid swirling in multiple canals at once. This creates a powerful, often overwhelming sensation of tumbling or rolling on a completely different axis.
Wow. So minimal head movements during instrument flight are key.
Absolutely critical. Keep your head steady during your scan, especially. Then there's the inversion illusion. A quick change from climb to level flight can feel like you're tumbling backwards. And the elevator illusion, a sudden updraft feels like a pitch up. A downdraft feels like a pitch down.
The common thread seems to be weird sensation equals check instruments immediately.
That's the mantra. Don't trust the feeling, trust the gauges.
Okay, moving on from the ears. What about the postural system? The nerves in our skin, muscles, joints, our seat-of-the-pants feel.
Well, those nerves tell our brain about our body's position relative to gravity, pressure points, things like that. On the ground, it's useful. In flight, though, acceleration forces can mimic or overpower gravity.
Like in a turn.
Yeah, even a coordinated turn creates a force that feels a bit like gravity pushing you down in the seat. An uncoordinated turn, a slip or a skid, can give you a distinct feeling of tilting or banking that might not match the actual bank angle. Turbulence obviously throws confusing signals at the brain, too.
So seat-of-the-pants flying isn't reliable in IMC.
Not really. It works okay for very gentle maneuvers in smooth air, maybe, but any significant acceleration, uncoordinated flight, or turbulence can completely fool those sensations. And remember, fatigue or being unwell can make all these disorientation effects much worse.
Right. So we've covered vision limitations, inner ear illusions, body sense illusions. What about specific visual illusions that happen closer to the ground, like during landing?
Yes, these are really important because you're transitioning back to relying more on visual cues, but Those cues can be deceptive.
Like the false horizon.
Exactly. Slipping cloud layers, an obscured horizon, certain ground light patterns, even the aurora borealis can be mistaken for the actual horizon, leading you to put the aircraft in a dangerous attitude.
And autokinesis.
That's where if you stare at a single point of light in the dark for too long, it can appear to move all by itself if you try to follow it.
Wow.
Well, you can see the problem.
Yeah. Then we have the runway-specific ones we touched on earlier. Width, slope, terrain.
Right, reinforcing those. Narrower runway looks like your higher, lower approach. Wider runway looks like your
Yeah.
lower, higher approach. Upsloping runway or terrain looks like your higher, lower approach. Downsloping runway or terrain looks lower, higher approach.
And the black hole approach.
That's the featureless terrain illusion. Flying over dark water, unlit terrain, snow-covered ground at night. There are no peripheral cues to judge your height. It makes you think you're higher than you are, leading to a dangerously low approach.
All variations on misjudging your height.
Pretty much. Then add in weather effects. Rain on the windscreen can refract light, making the runway look lower than it is, so you think you're higher, lower approach. Haze makes things look farther away and higher tendency to fly low. Exceptionally clear air, like at high-altitude airports, can make things look closer, tendency to fly high. Fog can create an illusion of pitching up, tendency to steepen the approach.
Even ground lights can fool you.
Definitely. Bright runway lights in an otherwise dark area can make the runway seem closer, higher approach. Rows of streetlights might be mistaken for runway lights. You really have to be vigilant.
Okay, that's a whole minefield of potential illusions.
Yeah.
Given all this, what are the key coping strategies? How do we manage this risk?
Well, first is understanding. Know these illusions exist, know what causes them, and stay alert for conditions where they might occur. Experiencing some of them safely in a simulator can be very eye-opening.
Preparation seems key, too.
Absolutely. Always get and understand a thorough pre-flight weather briefing. Critically, obtain proper instrument training and maintain proficiency before you even think about flying in marginal visibility or without a clear horizon, especially over water or at night.
And don't push into conditions you're not equipped or current for.
Please don't. If using outside visuals, make sure they're reliable, fixed points. Avoid sudden head movements, as we discussed. Be physically prepared. Adequate rest, good diet, allow time for night adaptation, and be acutely aware that illness, medication, alcohol, fatigue, sleep loss, even mild hypoxia dramatically increase your susceptibility.
But the number one strategy.
Become proficient in using your flight instruments and rely on them. Learn to trust what they tell you, even and especially when your senses are screaming something different. That is the absolute bedrock of safe instrument flight.
And for those landing illusions specifically.
Anticipate them, especially at unfamiliar airports or in poor weather or at night. Check airport diagrams, the chart supplement, AFD. Refer to your altimeter constantly, day and night. If possible, maybe do a visual flyover of an unfamiliar field in daylight first.
Use available aids.
Definitely. Use VSI, PAPI, or any electronic glide slope whenever they're available. On non-precision approaches, use the visual descent point, VDP, if it's charted. Recognize that distractions during approach increase your risk. And just generally maintain peak proficiency in your landing procedures.
It really sounds like understanding these human factors, these illusions, is just paramount as you progress, especially if you're flying IFR or at night.
It absolutely is. It's not about being scared of them. It's about respecting them, understanding your own physiological limitations, and knowing how to use the tools and techniques, primarily your instruments, to overcome them.
The big takeaway then is that critical need to trust your instruments, even when every fiber of your being is telling you something else.
That's the heart of it. Developing that instrument proficiency and maintaining vigilance against these sensory traps will make you a much safer, much more effective pilot.
Well, hopefully this exploration has shed some light on these fascinating and sometimes challenging aspects of human factors in aviation.
It's a deep topic, but hopefully a useful overview for everyone listening.
Thanks for listening.